Physics, October-November 2015, Paper 12, Part 2. Question 11. A single horizontal force F is applied to a block X, which is in contact with a separate block Y as shown. The block remains in contact as they accelerate through a horizontal frictionless surface. So you can see two blocks and there is a force. This horizontal surface is a smooth surface because they have mentioned it's a frictionless surface. Air resistance, we are neglecting it. And they have also told the mass X is greater than mass Y. Which statement is correct? Before going to the statements, let's find out the acceleration. The acceleration is for both the masses because the force acts on both the masses. So the force causes both blocks to accelerate. So force is equal to mass into acceleration. Mass should be equal to the combined mass of X and Y. Therefore, acceleration is equal to F is equal to F divided by mx plus my. Now let's check the statement. The accelerations of X is equal to force divided by mass of X. The acceleration is not only the force divided by mass of X, it is the sum of both the forces. So the statement is wrong. The force that X exerts on Y is equal to F. The force exerted by block X on Y is mass of X, that is the one which is exerting a force on Y, into acceleration. So acceleration, we have already got this value. Force over the sum of the mass. So as you can see, the numerator is smaller than the denominator. This is obviously less than the force, which shows that mass exerted by X, the force exerted by X on Y is not equal to F. So this answer is wrong. The force that X exerts on Y is less than F. So we have already mentioned it is less than F. So the answer is C, but we can check for the option D too. The force that X exerts on Y, this part, which is this one, is less than the force that Y exerts on X. So what they are saying is the force that Y exerts on X, that's going to be M Y and sum of the M, sum of both the masses Y and X into force. So this is the force that is exerted by block Y on X. As you can see, the mass of X is greater than mass of Y. The numerator is greater here. As a result, this value will be greater than this value. But option D mentions this force is less than the force that Y exerts on X, which is incorrect. Therefore, the option is C, and that's the answer. Question 12. A mass of 0.20 kg is suspended from the lower end of a light spring. A second mass of 0.10 kg is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium. This is very important. And then the thread is burned through. At this instant, what is the upward acceleration of 0.20 kg mass? We have to assume g is 10 meter per second square. Observe this arrangement. There is a light spring with a mass 0.20 kg connected to a light thread with another mass 0.10 kg. It's allowed to come into static equilibrium. That means the downward force is balanced by the upward force. And after that, they are burning through this thread. And at that instant, this mass will fall down. At that instant, what is the acceleration on this mass? Let's find the force before the thread is burned. Downward force is due to the combined mass, so 0.30 kg, but weight is mass into g. Here in this case it is 10. 0.30 into 10 gives me 3.0 Newton. The downward force is equal to the total upward force, which is 3.0 Newton, because it is in static equilibrium. At the instant when the thread is burnt, this mass falls apart. At that instant, the downward force is only due to this weight, 0.20 kg into 10, 2 Newton. So before the thread is burnt, the force is 3 Newton, but when the thread is burnt, the downward force is 2 Newton. So the resultant force is 1 Newton. And what's the acceleration on this mass? Its force is equal to mass into acceleration. Acceleration is equal to the force, which is the resultant force, 1.0 Newton, divided by the mass that we consider for the acceleration, which is 0.20 kg. So the answer is 5.0 meter per second square. The answer is here. And therefore, the answer is option A. Question 13. An object of mass m traveling with speed v has a head-on collision with another object of mass m traveling with the speed v in the opposite direction. So before collision, two identical objects with the same speed, they are approaching each other. That's what they meant by head-on collision. The two objects sticks together after the collision. The two objects sticks together after the collision. What is the total loss of kinetic energy in the collision? As you can see that we don't know the final velocity, whether they stick together and stay stationary or whether they are moving with another speed. We need to find the loss in the kinetic energy, so we need to know the final velocity. Let's take the momentum. Due to conservation of momentum, we know the momentum before collision is equal to momentum after collision. So momentum before collision, they're approaching each other. So mass into velocity minus mass into velocity is equal to, when they stick together, their mass is 2m, m plus m, 2m. Final velocity, I'm taking it as vf. Now, when you subtract, this amount is 0, so the final velocity is 0. If the velocity is 0, your kinetic energy will also be 0 after collision. Before collision, you can take half m v square plus half m v square. So before collision, the kinetic energy is mv square. After collision, the kinetic energy is 0. So the total loss of kinetic energy is mv square minus 0, which is equal to mv square. So your option is C. Question 14. Two identical spheres, x and y, approach each other with the speeds shown and undergo a head-on elastic collision. Elastic collision means not only the momentum is conserved, but the kinetic energy is also conserved. So first thing, let's check for the momentum before collision. Towards the right, if an object approaches to the right side, it's a positive direction. If it's moving to the left side, it's a negative direction. So momentum before collision, let me consider the mass to be m because they are identical. Both of them have a mass of m. So the momentum of x is the speed into mass, so 4m, and the direction is in the opposite direction for y, so minus 2m. So momentum before collision is 2m. And the kinetic energy is also conserved. So we have to just add the kinetic energy of both. Half m v square, so it's 4 square, plus half m v square for this, that is 2 square. The kinetic energy is 10m. Now let's check which option conserves the momentum first. This one is going forward after collision. So sphere y moves towards the right. So 2, but there is no momentum here. So your momentum is 2 minus 0. So it's 2m. So it's the same as the one momentum before collision. So the momentum is conserved for option A. For option B, 4m towards the right, and again velocity is 2 and momentum is 2m, that is also towards the right, so it becomes 6m. M is for the mass, they are identical, so it becomes 6m. So it's not conserved, that is not the option. We have to check whether we get 2m after collision. Here it is 4m towards the right and 2m towards the left, so minus 2m. So the final answer is 2m. So you can see it is conserved before and after momentum is conserved. This could be an option, or this could be the option. Let's check. This one towards the right, 2m, and this is minus 4m. So there is a sign change. That means the direction of the momentum after collision, it moves in the opposite direction. So there is minus 2m. There is no minus here, so that's not the option. So now we know the answer is either A or B. Now let's check for the kinetic energy. Now for kinetic energy of sphere X after collision, it becomes 0. And for sphere Y, half m2 square. So it just becomes the kinetic energy after collision is 2m. So it is an inelastic collision. Kinetic energy is not conserved. So this answer is wrong. So the only option is C, where the kinetic energy is half m2 square plus half m4 square. That gives me 10 m. M stands for the mass of the identical spheres. So the option is C. Question 15. Which pair of forces acts only as a couple on the circular object? A couple, it means that two equal forces acts in opposite direction with the same magnitude of force. So that is couple. Now we have to identify couple here. It should be equal force but in opposite direction. As you can see, this one, it's an equal force and they are moving in opposite direction. So this could be the answer. Let's check option B. They are not equal force and they are on the same direction, not the answer. They are on the different direction but not the same force, so not the answer. They are of the same magnitude of force, but the direction is not in the opposite. They are in a different direction, so option D is not the answer. The only possible answer is option A. A car of mass 500 kg is at rest at point X on a slope as shown. A car is at rest at the point X. The car's brakes are released and the car rolls down the slope with its engine switched off. So the engine is switched off and the car rolls down. At point Y, the car has moved through a vertical height of 30 meter and has a speed of 11 meter per second. What is the energy dissipated by frictional force when the car moves from X to Y? As you can see, this slope has a friction and that's why they are asking to find the energy dissipated for the frictional force. As you know, at this place, at point X, this potential energy is maximum. When it reaches the point Y, the energy has been converted to kinetic energy, but you should also remember that there are some energy that is being lost for the work against frictional force. So as the car rolls down the slope, its gravitational potential energy is being converted to kinetic energy and work done against friction. Potential energy is mgh, kinetic energy half mv square plus work done against friction. Make this one as the subject as this is what we have to find. So potential energy minus kinetic energy. mgh, so mass is 500 kg, g is 9.81, h is the vertical height 30 meter, minus half into mass 500 kg and the speed gained that is 11, so v square 11 square. So the final answer is 1.2 into 10 to the power 5 joule. Therefore, the answer is option B. Question 17. In which situation is no work done? The air in a bicycle tire is released because of a puncture. When there is a puncture, air is released. That means there is an increase in the volume. That means work is done by the system. So work is done. It's not the right answer. You have to find where there is no work done. A ball is dropped and falls to the ground. So when it falls, there is an acceleration. So when there is an acceleration, there is a force. When there is a force, there is a work done. So this is not the answer. A box moves at constant speed across a smooth horizontal surface. Smooth horizontal surface means it's a frictionless surface. It moves with constant speed. It moves with constant speed means acceleration is 0, which means the force is 0. So no work is done in this instant. So options should be C. Let's check D. A crane lifts a steel girder at a constant speed. Even though it's lifting at constant speed, to lift it has to do work against the gravity. As a result, option D is not the answer. Therefore, the answer is option C. Question 18. An electric railway locomotive has a maximum mechanical output power of 4.0 megawatt. Electrical power is delivered at 25 kilovolt from overhead wires. The overall efficiency of the locomotive in converting electrical power to mechanical power is 80%. What is the current from the overhead wires when the locomotive is operated at its maximum power? As you can see, the efficiency of the mechanical power is 80%. The output is 4.0 megawatt. Electrical power delivered with the voltage of 25 kilovolt. Now they're asking us to find the current for the overhead wires when the locomotive is operating at maximum power. So as we know, efficiency is equal to power, output power by input power, and power when voltage is given. To find the current, we can take this formula: power is equal to VI. Efficiency is 80%, so I'm taking it as 80 over 100. Output power 4.0 mega, mega is 10 to the power 6. 25 kilovolt is the voltage, so 25 into kilo, 10 to the power 3 into I. We have to find I, so I make I as the subject. I get 200 ampere. So the answer is C.